triangle postulates. So remember that last class we were proving triangles congruent, but the way we had to prove them congruent is that we had to prove all three angles were congruent and all three sides were congruent. In these postulates, we only have to prove three things. So these are really shortcuts, okay? So we have, so I gave you a foldable. So you should be using the foldable. We have angle, angle, side. Remember, we have angle, angle, side. So it states if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. Alright, so remember I told you that the congruency statement is important. It names it. So this was angle, angle, side. So notice that I put A's next to the angles that are equal and S's next to the sides equal. So it lets me know that this is angle, angle, side. Angle, angle, side. And also on my congruency statement, remember the first one, you can name it however you want. But the second one, you have to name how you named the first one with the corresponding parts. So angle A went with angle D, B went with angle E, and C went with angle F. Some vocabulary that I need to make sure you're familiar with is non-included. Non-included means it is not in between the angles. So this is the angle and this is the angle. This side is outside of the angle. Okay? So that's why it's non-included. Okay, look at the example on the outside of the flap and see if you can figure it out without me first. And then press play. Alright, so you should have noticed that Q was the middle letter and so was M. So that means they are equal. So M was 110, so Q was 110. You should have noticed that MN was the last two letters and QR was the last two letters, MN and QR. So that means that they're equal. So since QR is 12, MN is 12. Okay, this one reads, if two angles and an included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So this one's angle, side, angle. Notice it says included this time. So the included side is in between the two angles. Okay, it's in between the two angles. So I named the first one BCA. B goes with E, so I did it first. C goes with F, so I did it second. And A goes with D. Look at the example on the left-hand side. And try to do it without me first. Alright, now on this one, hopefully you found out x equals 3. They asked you to solve for x. And if you look at the congruency statement, A and C was the last letters. Well, you don't even need that, you need the angle. So angle A goes with angle F. So 12x equals 36. Or you could have done angle C goes with angle D. So you could have done 18x equals 54. And divided by 18 on both sides, so x equaled 3. Okay, the next one states, if two sides in the included angle of one triangle are congruent to two sides and an included angle of another triangle, then the triangles are congruent. So included angle, notice that the angle is in between the two sides, that's why it's included. I did triangle CAB. So since C has to go with F, and then A goes with D, and B goes with E. Okay, try the example on the left-hand side without me first. Okay, hopefully you found out the answer was 7. If you look at the problem, you should see that XZ is congruent to AC because they're both the first and last letter in the congruency statement. So you have 2y plus 1 equals 15. And then you should find out that y equals 7. And the next one, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Now put the congruency statement I did there. So triangle CBA is congruent to triangle FED. Okay, do the example without me first. Hopefully you found out that x equals 3 and y equals 3. It's a coincidence that they both equal 3 though. So you should have seen that the x minus 1, this side here, is equal to 2. And then the 3y minus 5 was equal to the 4. Okay. The last one is a hypotenuse leg. It is only for right triangles. Let me say that one time. The hypotenuse leg is only for right triangles. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse leg of another right triangle, then the triangles are congruent. Remember, the hypotenuse is the side across from the 90-degree angle, and the leg is either of the other two sides left over. Okay. So in this one, I said the triangle ABC was congruent to triangle ZXY. Try the example on the left-hand side without me first. Hopefully you found out that x equals 10 and y equals 10. Again, it's a coincidence that they are equal to each other. You should have looked at the congruency statement to see that A was congruent to D. And so you have 7x equals 70. And you also have 2y equals 20. Okay. Okay, and on the side somewhere, I want you to write these never work. Never work. SSA never works, and A never works. Okay.